we have Arjun Bhuptani with xNext, with a talk entitled Building xChain Applications with xCall.
Thanks. Hi, everyone. How's it going? Last talk of the morning. This talk is about cross-chain stuff and xNext. How many of you know what xNext is before I get started? OK, great. For the rest of you, I will be going through it. So, alrighty. So we live in this really weird and wacky multi-chain world right now. This is the Aave UI, and the experience of using Aave right now is, especially if you're a person that has funds living on multiple rollups all at once, is absolutely awful. So like if you, for example, want to invest into an Aave pool, but you're trying to find the best rate to lend into, if you make the mistake of actually lending in the wrong market, the process to get to the right market is god-awful. Basically, you have to pool your funds. Not only do you have to kind of select through each and every single one of the chains on Aave to be able to figure out where the best rates are to begin with, you have to pull your funds out, go find a bridge, hopefully a bridge that is safe and is giving you the right assets on the destination chain, and then hopefully also has a good price, and then go back to the Aave UI to lend again onto the platform. That's something that, for people like us who have been in this space for a while, it's a giant pain. And for new users coming into this space, this is completely unintelligible. I mean, try explaining to a new user who has never interacted with blockchains before what the difference is between Arbitrum 1 and Arbitrum Nova. They really just don't know or care. And really, what we want is this cross-chain experience, right? We want an experience where, as a user, you are interacting with a single unified interface, and behind that interface, you are able to invest into whichever Aave pool you want. A good analogy is something like Google search, right? When you search for cat photos on Google, you're not consciously aware of the fact that Google is in the background running a search across all of their index data across multiple sharded databases. You're just seeing cat photos, and that makes sense. Users don't need to know what's going on in the background. The fact that we force them to know that right now is absolutely terrible. And I know some people in the audience are now like, oh no, he said the C word. Look, it's no secret. Cross-chain is really, the reputation of bridges and cross-chain is absolutely in the shitter right now. And it's fair. There's a good reason for that. We've lost $2 billion in hacks in the last year. And I think it's because, as a community, we've really undervalued and underappreciated the extent to which bridges play this very, very critical role in our ecosystem as a piece of infrastructure that helps connect all of the different chains, not only other alternate L1s, but also rollups and other chains within the Ethereum ecosystem. We've really not spent enough time thinking properly about how to make them secure. And this also brings up the other question, which I think always comes up anytime there's a bridge hack. Do we even need bridges? Why do we actually need them? And the answer to this is yes. I mean, there's no real way around it, right? Because every single time there's a bridge hack, you'll undoubtedly have some person on Twitter post saying, oh, well, if we were using rollups, this wouldn't happen. But that's also not true, right? Bridge hacks largely have been implementation bugs, and rollups are also bridge implementations. Rollups post data to their underlying DA chains, which is a bridge. Eventually, when we move towards a more modular world, those DA layers will post their data to underlying consensus and settlement layers. That's also a bridge. And not just that, we also need to be able to communicate between the rollups, because again, we want to make sure that users have a consistent experience. So execution layer to execution layer communication, also a bridge. It's all bridges. We are heading towards a world where everything is going to be layers and bridges. Because bridges, really what a bridge is just a way to synchronize data between two distributed data sources. And so if we're living in this world where we do have to have bridges, no matter what, how can we find ways to actually build safer bridges? And there's a bunch of things here. Fortunately, there are actually answers to these questions. It's just that we haven't collectively had enough time to figure that out yet. And unfortunately, the bridge market matured really, really quickly in a bull market where everybody was really, really focused on growing rather than actually finding the right way to build these things. But there are ways to actually simplify bridge infrastructure and reduce the risk. For example, we can modularize the bridge stack. What this means is, I know modularity is a bit of a buzzword, but what this really means from the perspective of bridges is separate out each piece of the life cycle of making a transaction that goes across chains and isolate the risk of each of those pieces. So for example, have a transport layer, which is really just a mechanism to take hashes from here and then put them over here. right? And have that be separated from the verification layer, which proves that that hash is actually correct. And have all of that be separated from the execution layer, which takes a hash that now you know to be correct and executes a function call or some data against it. By separating out all of these components, we can actually end up in a world where you can mitigate the risk by isolating all of your risk only to the verification layer, or something like that. Aside from that, there's a bunch of other really easy tactics, too. Minimizing external dependencies. I'm really, really bearish on bridges that use lots of fancy cryptography, because the cryptography implementations on each chain are actually very different, and even on rollups are completely different. And they all have artifacts. Those artifacts will become relevant if you are living in a world where you're trying to use the same complex cryptographic protocol on every chain all at once. But even beyond that, minimizing external dependencies means using what already exists, right? We have an existing network of arbitrary messaging bridges between all of the chains in the Ethereum ecosystem. There's the rollup bridges, there's the Gnosis Chain AMB, there's the Polygon POS bridge, and users are already inheriting the trust of those systems. If you are building a system on top of the Polygon POS bridge, and the Polygon POS bridge gets hacked, the entire Polygon ecosystem is kind of fucked. Like, there's not anything anyone can do about it. And that means that there's, of course, that is a systemic risk that we have to be concerned about. But it also means that when you're building on top of that bridge, you're not adding any additional trust assumptions for the user, which is actually a really good thing. Separately from that, there's also delays and off-chain watchers. So this is basically fraud proofs. Similar to optimistic rollups, you can add delays to bridging interactions and have a network of watchers that can halt the system, basically pause or disconnect a chain if something goes wrong. This is powerful because it basically means you can have, again, similar to an optimistic rollup, have a one-event system where you only need one person really watching the system to be able to make sure that you have safety, and that safety is preserved when you're moving data and funds across chains. And then lastly, and this is a relatively new concept, rate limits, right? If you think about it, logically, there's not really any reason why, if you have a bridge that has $100 million in it, there's probably not any good reason why 15, 20% of that should disappear. And so it's actually fairly trivial to bake in on-chain rate limits, where you can say, OK, more than X percentage of the funds within the system have left in the last 15 minutes, something is wrong. And that should trigger an automatic halt, or at least disallow additional people from withdrawing funds. These are kind of ways that we can stop attacks before they happen, or even if they are in the process of happening, at least curtail the risk. Because otherwise, you have this broader risk of contagion, and something that we've started to see a little bit, which is a bridge gets hacked, or an ecosystem gets this could happen to a rollup bridge too, which is a nightmare scenario. But a bridge gets hacked, and all of a sudden, every single asset that is on that chain is now unbacked. And that entire ecosystem implodes because everything that was worth one of itself is now worth zero of itself. How does Connext work, and how do we kind of play into this model? So Connext is a mechanism for cross-chain communication. We're trying to find the right, safe way to build bridges and build ways for people to build cross-chain applications. The way that we do this at the moment is by, as I mentioned earlier, modularizing. We send messages through existing bridges, things like the rollup AMBs, Gnosis Chain bridge, et cetera. Those bridges take a slow path, quote unquote, which means that they, any data that goes through these bridges is posted to Ethereum, and then is batch posted to every other chain. And then we have an execution layer that sits on top of all of that basically relays data and funds in a fast path method. And what this means is that you have a network of off-chain actors that are fronting capital, and in some cases, in some specific cases, able to even call contracts to execute transactions across chains, and then reconcile against messages that come later using the slow path. And importantly, what we do is we introduce a 30-minute delay in watchers to every single AMB that we use. So effectively, what we're doing is, again, similar to a rollup, creating fraud proofs that can secure the system even further beyond any the security that the AMB provides. It's kind of nice. Where regardless of whether or not the bridge that we're using as transport, so basically the data that is going across chains in the slow path is basically just being posted between chains. It's the transport layer. So regardless of what the security is of the bridge that we're using, we are adding our own security. We're basically turning every bridge into an optimistic bridge, whether they want it or not. What does this mean? And what does this actually let you do? Connext lets you build cross-chain applications. And this is something that we really, really believe is the holy grail of decentralized application development. We need to move from this paradigm of having applications living on one chain to having them live on multiple chains, rollups, et cetera, all at once. And until we do that, we will just continue having this really fragmented, shitty experience. How does Connext do this? So Connext introduces this really simple primitive called xCall. xCall is a way to do basically any kind of generalized function call across chains. It's a good analogy is to think of Solidity's built-in call method. And in the same way that call lets you call a contract on the same chain, xCall lets you make an asynchronous call to a contract on a different chain. What does asynchrony mean? Kind of a good mental model here is to think about how we do web development today. So when you're building a web application that's using JavaScript or whatever, you are interacting with resources that exist on servers all across the globe. You're not actually just hitting a single machine. And that's a core part of how we think about building on the internet, right? Because it's not possible to make sure that there is data available everywhere that you're trying to build all at once. And implicitly, the assumption here is you're going to go fetch data from some remote resource. You need to know, you might not know whether that data will come back. You don't know when that data will come back. But you can wait on that data and then execute other kind of functionality based on when that data is returned. In JavaScript, these are callbacks. So we can introduce this core idea into Solidity as well and create what is called asynchronous Solidity. So again, you can have a source contract living on one chain, Optimism, for example, that calls a target contract on another chain, Arbitrum. Similar to JavaScript, that call happens asynchronously. So the execution of that transaction in a single block on Optimism ends, and then it begins an execution on another block on Arbitrum. And again, similar to JavaScript, you can then make a nested xCall back to the origin, or actually even to other chains. This is similar to a callback. The core idea here is very, very powerful, right? I can build an application that accesses resources. So I have my Solidity contract sitting on Optimism. I can build an application that accesses resources and funds living on any other chain, and do this with any kind of functionality. How do you think about gas in this kind of paradigm? It's a little bit tricky. But what we've tried to do is just constrain the complexity of this as much as possible so that it's as similar to existing development patterns. So with Connext, you just pay gas in origin chain native asset on the origin chain. You basically just include it as part of the message.value. If you don't pay enough gas, you bump gas. You just bump it, and then it gets processed faster. You'll see the execution halt if it doesn't actually complete because it ran out of gas. What does this look like in practice? Again, the goal is keep it as simple as possible, right? We want this to be a very simple primitive and an open kind of mechanism for people to build these kinds of applications that can just become a standard. Because the bottom line is you don't actually need a ton to call a contract somewhere else, right? You need to just know where you're calling the contract. So the target contract address and the destination domain. Domain is chain ID, but also kind of broadly applies to other kinds of things that may not have a chain ID one day. And then you need to specify data that you're passing between chains, and asset and amount params in case you want to send along funds. What can you build with this? This is where things get kind of interesting. Because this is such a generalized primitive, we've seen a lot of projects building all sorts of really interesting use cases. And I think that's honestly something that I am most excited about, is that cross-chain development unlocks not just let me take Aave or Uniswap and make it a cross-chain application, but also a whole host of other kinds of new use cases that people haven't really thought about a lot. Some basic ones are Superfluid is building cross-chain money streaming. So basically set up a stream on one chain, pay it out on any other chain or multiple chains simultaneously. Keeper Network is bridging Uni v3 TWAP oracles to every other ecosystem. So Oracle dependencies, the consistent problem that a lot of projects have with being able to deploy on new chains or new ecosystems is not having an Oracle available. And even if you do have an Oracle available, there are still a lot of projects that really do want to have Uni v3-like oracles that are not relying on external actors, things like Chainlink. So being able to, in a fully trust-minimized, secure way, actually bring that Uni v3 TWAP data across chains is extremely powerful. FujiDAO is actually building the solution to the problem that I mentioned at the start of this talk, which is they're sort of like a lending aggregator. They allow you to borrow on any one chain and lend on any other chain. And the way that they do this is by plugging into Aave and other kinds of lending pools across all chains and providing users with a seamless interface rather than one where they have to, again, jump between chains all the time. NFT Hashi is bridging NFTs between chains. They're a bridge and protocol. The thing that's really powerful about this is if you look at like the NFT ecosystem today, it's almost entirely isolated per chain. So like, you think that Treasure DAO's marketplace competes with OpenSea, but it doesn't, because there's no the NFTs that Treasure DAO, like their marketplace actually deals with, are the ones that are on Arbitrum, and then OpenSea deals with an entirely separate set of NFTs. And this creates a bit of a not just a fragmented experience, but also just a bad market for NFT marketplaces, right? You want to be able to go where the collections are, even if your implementation is built somewhere cheaper. And lastly, and this is actually one of the ones I'm most excited about, is Gnosis Zodiac. Gnosis Guild is building a project called Zodiac, which is basically a DAO tooling ecosystem. And one of the key things that they're doing there is building cross-chain DAO governance and voting. So the idea, like a good example of how this would work, for example, is say you have Uniswap trying to update fee tiers on Polygon from its DAO running on Optimism. How do they do that, right? That you don't want to have to deploy a copy of the DAO on Polygon just to be able to update, and create a 1 BPS fee tier. What you want to do is allow people to vote on Optimism, where Uni tokens are already available, and take the outcome of that vote, take it across chains, and use it to call a contract on Polygon. And I think there's a much kind of broader array of use cases here around cross-chain governance that I think projects are now starting to run into because they're managing deployments across multiple chains at the same time. Separately from these are projects that are being actively built, but I think there's a bunch of other really interesting things that are near and dear to my heart. For example, I think like cross-chain yield vaults are very interesting. The entirety of the market for bridges at the moment is basically people chasing yields. You can destroy that entire market just by creating a single vault that aggregates yields from everywhere. It's pretty fascinating. Another really, really cool one is basically allowing metaverses like Decentraland, Sandbox, et cetera, to interoperate. These are completely isolated systems living on pretty much completely isolated chains, but there's no reason why you can't port pieces from one to another, or actually even build a portal that allows people to go from one metaverse to another, taking all of their stuff with them. And lastly, this is actually the one that I'm most excited about. There's no reason why cross-chain communication needs to be limited to EVM chains. There's no reason why it even needs to be limited to stateful execution blockchains the way that we think blockchains work right now. In fact, you could build connectors into things like Arweave or Filecoin. And what this means is you can have communication that happens from within a Solidity smart contract living on Ethereum directly to storage living on Arweave. You can have contract-owned stored data. If you take this to its kind of like theoretical end state, and you have you have cheap execution layers, you have storage and basically data stores living on another chain. You can even plug in things like compute and caching. You can actually build full stack decentralized applications only in Solidity. That's really powerful, right? Like that's not just, oh, I built a 200-line, 500-line Solidity contract that is doing one very minimal thing because everything costs too much and it's too expensive to store any data on chain. I'm actually able to build an API that stores like global GIS data that can never be taken down. That's really where we get to like world computer stage, which is really it's something that, at least for me, that's why I got into Ethereum in the first place in 2017. Anyway, there's a lot out there, and I understand like this is a whole new world for a lot of folks. It is for us too. So we have about 5 minutes for questions, but in general, hit me up if you are interested in these topics, or if you want to hack on it at ETH Berlin.
Yeah, thank you, Arjun, for such a nice talk. And yeah, we have 5 minutes for questions.
Thanks, Arjun. This was super cool. I have a question about, you mentioned that every bridge essentially becomes an optimistic bridge, right? So that means there is this 30-minute waiting time. In what scenarios does the user actually have to wait 30 minutes for finality?
Yeah, that's a really good question. I wanted to add a slide in here, but I just ran out of time when making slides. So there's something that, so like obviously there's this broader concept of like generalized communication between blockchains. But there's actually like subsections of that, so you can actually break that up into certain kinds of things that can be done fast, and then certain kinds of things that require the slower path communication. And what that comes down to is authentication. Are you checking who the caller is on the sending chain? A way to build intuition around this is, for example, say you want to swap, like say you're on Arbitrum and you have ETH or like USDC, and you want to swap $100 worth of USDC to ETH. But the best price that you're getting is on Optimism. You actually don't need generalized communication to do that. Because what you could effectively do is like lock that $100 of USDC into an escrow, and I could pay a service provider and say, hey, like, can you swap $98 worth of USDC into ETH and send me the result on Optimism? And then if you do that, I will unlock from this escrow. And there are trustless ways to do that. And so as a result, that can happen instantly. On the other hand of that, obviously something that is like a DAO-owned function or an only owner function can't be done that way, right? Because there's no real service provider that you could ever delegate to like call that contract function without actually giving them ownership of the contract. Basically, the way that it breaks out is if you're checking message.sender, like the TX origin on the destination chain contract, it'll go through the slow path. And that actually happens automatically in our system. So like when our routers, which are like the entities that are providing liquidity and executing transaction data, when those routers see a new transaction attempting to be sent between chains, they'll actually just run a gas estimation on it. So they're dry running and seeing it. If it fails, particularly if it fails because there was a message sender check that failed, then they know that this is something that has to go through the slow path. Yeah. Cool. Any other questions?
All right.
Awesome stuff.
No more questions, then thank you so much, Arjun.
Thanks so much.